Good morning everyone, my name is Dave Whiteley. I'm Technical Director of Envisageukltd, and I'd like to take this opportunity to show you Autodesk Inventor iLogic. Now Autodesk Inventor iLogic is in effect a macro-based language that embodies the Autodesk Inventor product, and it enables you to apply rule-based design from parts and assemblies within Inventor, as well as controlling drawings from a macro language. This is now included in Inventor and has been for a number of years, and I want to show you an example of how we would drive an assembly from iLogic. First of all though, what's the difference between iLogic and other means of creating automated assemblies and parts in Inventor? A number of you will know about iParts and iAssemblies, and these are relatively easy to define, but they can be problematic if you want to certainly automate them from, say, XML or external files, and also control logic more deeper than you can with just using iParts and iAssemblies. We can use Excel-driven models within Inventor. This enables us to use standard Excel industrial tools to actually drive the models. We cannot change certain things using Excel, and it gives us a limited a way of driving parts and assemblies. Whereas with iLogic, with little programming knowledge, you can drive a part or an assembly together with an embedded dialog box to control a part or an assembly that perhaps is a product that you as a company design and provide to customers, but you only really want to model it once and then drive it from iLogic to change size, color, material, and so on and so forth, but also put in a certain amount of control so that somebody can't put in stupid sizes, for instance, and you get the feedback from iLogic to tell you that you're using wrong sizes and that you need to be using a particular range, and so on and so forth. So you can put a lot more logic into the Inventor model of driving an assembly using iLogic of a steel cabinet. So what we've got here is an assembly made up of a number of sheet metal parts and standard Inventor models. And the first thing that I want to point out is if you're going to drive a part or an assembly from iLogic, it is important to actually rename either the parts or the features in the browser here on the left hand side. Certainly if you're driving features, you really want to rename them, because these are the names that are going to be driven from iLogic. So for instance, the outer part here is called outer, we've got the kick panel down the bottom called kick panel, and so on, as opposed to outer:1, outer:2, and so on. So we actually rename these, and they're much easier to drive from iLogic. Let's have a look at the outer panel first and see what we've done here. If we have a look at the parameters of this part, you'll notice that certain dimensions in this sheet metal part have been renamed. So the width and the height and the depth have been renamed here. Be careful, these are case sensitive. In this case, the parameters have been put in at lowercase. Programmers tend to put the first letter as uppercase and the rest as lower, but just remember what format that you're actually using when you give these names. Now, in Inventor, in standard Inventor, it's very difficult to actually be able to drive parameters within embedded parts in an assembly. If you were doing something like skeletal modeling or multi-body modeling, then you would be able to do this sort of thing. But because we've got an assembly here, and I want to drive this assembly and chisel down, if you like, to the sheet metal parts within this assembly and drive their parameters, the only way we can do this is using iLogic. But I need to make sure that initially the parts are set up so that if we look at the kick panel, for instance, same sort of thing. If I open this up and have a look at the parameters, in here we've got width and height, which are the parameters that I need to drive this sheet metal part with. That's the first thing. So we name our parts, we make sure the parts have got relevant parameters within them, and then we could probably start then driving this using iLogic. Within the assembly itself, the parameter I've got here is one I'm using here is draw spacing. This controls the pattern of the drawers themselves. So if we edit the pattern, I'm using a parameter here, draw spacing, and again this I will want to control from iLogic. So certain things are going to be controlled and driven from iLogic within parts, the embedded parts in assembly, but also I'm able to drive the parameters within the assembly itself. Now before we actually start looking at iLogic code, the first thing I want to do is have a look at what's new in parameters within Inventor. You're used to adding numeric parameters. We've got this user parameter of draw spacing that's been added, but I want to add some extras. Now we can add numeric text and true false, i.e. Boolean parameters within Inventor. We tend to use the numeric if we were using standard Inventor functionality, but we have text and true false available to us that we would really only use from iLogic. I'm going to add a numeric value here called width. And in here I'm going to add this, give this a value, say 600. We'll add another one for the height, give this a meter. And another one for the depth. And we'll give this 600 as well. Okay, so there's some parameters that I've set up within my assembly. I'm now going to make these multi-value, and in this case what I can do is I can add some other values to a table such that I've now got a pull-down list that I can use to drive this assembly from. And likewise we'll do the same with the height. And with the depth. Okay, we'll make these key values, and the reason why we make these key values is that we can actually shorten this dialog box in a minute. The other thing I'm going to do is I'm going to add some text, and this text I couldn't use it in Inventor, standard Inventor, but I can use it in iLogic. And let's call this style, and we'll have a style for the UK. We'll make this multi-value, and we'll have a style for Europe, and we'll have a style for US. Okay, again we can choose from a pull-down list our options here. Again, we're going to make this a key value. If I click on less and filter here for key values only, I can now actually make the parameters dialog box a lot smaller and easier to access. If I now change, say, the height to 1200, this will drive the height values, the height parameters, and it will drive the assembly such that the values alter. Because we've got immediate update on here, then we have the ability to, as soon as sizes change, then the parameters change on the assembly. Okay, we've got a problem with these, so we just give these uppercase values. Okay, Now that we've got our model set up and everything, let's just have a look at this outer part a second here. And we'll have a look at the parameters. Take the filter off. One thing you need to remember is when you use filter, when you go back to parameters in other components later on, you need to remember to change this to all, because this is remembered throughout the Inventor, your Inventor, so you've got to remember to take that off afterwards. Okay, so we've now got our assembly set up. We've got our parameters within the parameter dialog box here, but nothing's going to drive yet, because all these are just names in a parameter table that have no effect on the assembly so far. So for instance, if I change the width, it's not going to change this assembly yet, because this is just changing a value or a parameter called width. But width is not used in this assembly. It's actually used in parts within the assembly. So I now have to use some logic to take these values and then start driving parts within the assembly. So now we can start looking at iLogic. So if we go to the Manage ribbon, we've got an iLogic section of the ribbon, and we're going to click on the button to actually put the browser on, the iLogic browser on. This gives us another browser on the left hand side here, which shows us the rules that are embedded within this model, or any external rules that we want to apply to a number of Inventor models. Alternatively, as well as those rules, we can actually add forms that are again either embedded within the model or are global forms that drive a number of models. In this case, it's all going to be embedded in this assembly file. So we add a rule. You can add as many rules as you like. I'm adding one here, and I'm just going to call this sizes. And this will start off by giving me what looks at first like a complicated dialog box, but actually it's relatively simple. This is where we write the code. The code is loosely based on VB. These are the snippets that we can grab, so we don't have to remember code. We can actually go to the snippets, find the relevant section, and then, for instance, if I want to change a parameter within a part, I can find that particular parameter, double click on it, and it adds the code in the screen here for me. Now, first of all, we need to look at what user parameters we have available to us within this assembly. These are what I've just added to my parameter table, and they've come through as options for me to use here. Now, what I'm going to do is I'm going to set up some variables. So I'm going to call one iWidth, and I'm going to make it equal to the width that's coming from the parameter table, and likewise the same with iHeight and so on. So I can then use these particular parameters within my code, as opposed to using the parameters coming from the parameter table. You don't have to do this, but it's easier to see what parameters you've got set up at the beginning of your code. Okay, so we've now got iWidth, iHeight, iDepth and iStyle, which are bringing the relevant parameters across from my assembly, and I can now use these within my code. So for instance, I may want to change the draw spacing, and the draw spacing is going to be equal to the height, which is iHeight because that's the parameter I've set up, minus 100 millimeters, minus 35 millimeters. So I'm actually putting some code, some maths in here, and I'm going to divide this by 3. So that's actually the code that I'm using to actually drive the draw spacing variable. So it's taking iHeight, taking 100 millimeters, or 135 millimeters off of it, dividing all that by 3, and that goes in at draw spacing. Now, that's just simple stuff now. We're just creating some parameters, and we're just making draw spacing equal to some maths based on other parameters. But now I want to start driving the parts within my assembly. So this is where I use the parameter component from the parameter snippets. And in here it puts the skeleton code in, if you like, where I can start changing things. And as you can see here, what we need to do is change this to the name of the part that we're going to alter. I'm going to alter outer, one of the parts. The outer sheet metal part is called outer. And in there I know that I've got a parameter called width. And I'm going to make that equal to width. So what's actually going to happen here is going to take the parameter called width that comes from my parameter table within my assembly. It's going to make it equal to width. It's then going to drive the parameter called width within the part called outer by that value width. And I can go on and add more parameters throughout this code. What I'm going to do here is just take a certain amount of code that I've already written and put it in here. Okay, so we've got the parameters, something here I'll talk about in a second, and then all the parameter commands, changing the parameters within the outer component, parameters within the base component, parameters within the draw front component, parameters within the draw base component and the kick panel, and various dimensions are being pushed into these parts based on maths coming originally from the width, height and depth of my parameter table within my assembly. So this is the intelligent code that's wrapped around my assembly that's driving parts, it's chiseling down into parts in the assembly and driving their values. If I now click on OK on this and then go up to the parameter table and just change some sizes, because we've got immediate update on, this then immediately updates the parameters. It runs the sizes iLogic routine and it starts driving components within my assembly, as we can see here. Let's take this a step further, because also I have a text parameter here called style. All I want to do simply here is, depending on the style I choose, I'm going to have a different kick panel color just down the bottom here, just something simple. So if you go ahead and edit the rule again, and down the bottom here, we're just going to use a simple if then else statement. So if the style, right, remembering that I created a variable called iStyle up here. Now this is interesting. You notice style here is brown and it should be blue. The blue parameters are actually coming from my user parameters in the assembly, but you'll note that I foolishly typed this in and I put an uppercase in here. Now if I go back to the parameters here and double click on it, it puts the correct spelling and the correct uppercase lowercase setup of the parameter, and it comes in as blue. So by looking at these immediately, I know that I've now got these correct. They're coming in from user parameters from the assembly, and they're now correct. The brown ones are parameters that I've created within my code. So we go back down to the style. So if iStyle equals UK as an example, then we'll do something. And in this case, I want to make the component color. Find the component color in the snippets of the kick panel. So the kick panel is available here. Double click on that to put it in. Equals, say, yellow. Now we could either do an else, or in VB, or Visual Basic, you also have an opportunity to do an else if. So in this case I can say, well, else if the style equals Euro, then, and of course I can just literally copy and paste code around here. The kick panel is going to be green, say, and then finally we'll put another copy in, but we'll embed that with an else, and then an end if. If it's going red, you've got the syntax right. There we are. So what's happening down here is that if the parameter, the text parameter, right, that we set up earlier on, called style, if it's equal to UK, then we'll make the kick panel yellow. If it's equal to Euro, then we'll make it green. Else, we'll make it yellow, Yeah, we just copied, so we'll give that another colour, red, say. Okay, let's drive that. Let's have a look. Notice it's gone green. We now change from Euro to say USA, and that will change the colour of the kick panel according to that else, if the else loop that I've put in the code. Okay, so there's the assembly being driven from the iLogic code. One other thing that you can do that I quite like is in the custom snippets, there is something here, I can find it, called the Windows voice command. You can actually make iLogic speak. So we could actually put in some code here. Okay. Now in this case, what I'm doing is I'm bringing in code. We'll just have a look at what the code is. It's just a bit of VB code where it loads up the voice DLLs that we require, but all we need to do is change the text in the double quotes after this .speak function to whatever text that we want to put into this speech. We can use this sort of function format. We can do it and some variable like this. This will work. So iLogic started, and then it'll read out whatever the value is of the style and so on. You can do that sort of thing. Just keep it simple. We then, if I get my microphone close to the speakers on the laptop, if I then run this,
iLogic started. iLogic ended.
You then get the famous Microsoft voice coming through, where you can actually, instead of putting perhaps errors or warnings up on the screen, you can actually have the speech do it instead. It's up to you.
iLogic started. iLogic ended.
Okay, so that's the iLogic rule written around my assembly. So we're starting off from the parameter table here, which we're filtering to just keys. We can then change these values, and as we alter these values,
iLogic started. iLogic ended.
it then updates the assembly, driving through the rule, the iLogic rule, and we're pushing the sizes through to the parts within this assembly. So that's that finished. Now what we've got to do, just to sort of icing on the cake really, is to actually create ourselves a dialog box, so that when we import this assembly into another assembly, we can actually have a dialog box come up to ask us what size we require. To create a dialog box, we go back to the iLogic area of the ribbon and add form, give the form a name. It will then give us a preview of the dialog box, which has got nothing in it at the moment, and a form editor for this dialog box. The first thing we'll do is look at the layout of the form. At the moment, the predefined buttons that we've got on this form are just done. I could add OK, cancel and apply, for instance, and it adds the relevant buttons to the bottom of the dialog box. One thing that we'd want to do is the show on place component is set to false. This will actually show a form when you're placing the model into an assembly. Well, we will want to see that form, so we need to change that to true. So that's the first thing done. Now we simply choose from our toolbox in the bottom left hand corner what we actually want in that dialog box. Well, it will be nice to start off with a picture, so we'll drag that into the window at the top right hand corner here. That'll give us a picture. Of course, we've got no image data yet. It needs to know what the image is. So in the properties of the picture down the bottom here, we can then choose the image line, go to the button with the three dots and choose our image that we're going to embed into our dialog box. That gives us an image of our component. Also in here we have a splitter line that we can put in, so that just gives us a line down the bottom here to delimit the picture from any inputs that we're going to add. And then you'll notice on the left hand side here it's found all the user parameters that are in the parameter table within my assembly, and I can just choose these with the shift key and drag these across, and then these will bring these across with pull down lists so that we can actually choose our sizes. You click on OK on that. In the forms part of the iLogic browser, we've now got the sizes dialog box, so we've got the rule and the form. Click on that. That will run up the dialog box so we can check this works. So for instance, we'll change the style to Euro. We'll change the depth to say 800. Click on Apply.
iLogic started. iLogic ended.
That's changed the kick plate color to whatever the Euro style is. It will then change the depth of the assembly itself. So it's pushing through to the components within the assembly and driving their values and updating the assembly accordingly, and then we can click on Close on the dialog box. It means now that if we were to save this and start ourselves a new assembly, place an iLogic component. Let's just save this. This will bring in the assembly and also the dialog box to go with it, where we can then start changing sizes and so on.
iLogic started. iLogic ended.
And that will drive the sub-assembly that's being pulled into our GA here, and then the dialog box will enable us to choose whatever sizes we require, use the intelligence of the iLogic code to then create ourselves a version of that sub-assembly as driven by the iLogic code. So there you are, there's a run through of iLogic. Hopefully you found that of use. My contact details, should you wish to contact me, are there. Thank you very much for attending. Look forward to presenting another webcast in the future. If you need to see the previous webcasts of ours, then go to YouTube and search for Envisageukltd. There's about 20-25 videos on there on different Autodesk products, Inventor, Showcase, Publisher, etc. And thank you very much.